Hi everyone, this is lesson 423 on inverse trigonometry. The last few lessons we've talked about finishing up the trig ratios. And so as a reminder, again, here's our sine, cosine, tangent ratios that we've been discussing in case you need those as a reminder. We also talked about how to remember these using SOHCAHTOA, either probably most commonly, you might see this written out in some books or online. I like to write it using fractions, so the way it's a little bit easier to remember what goes on top and what goes on bottom. Right, so I'll still say SOHCAHTOA, except I try to remember what goes on top and what goes on bottom. All right, so we're using these trig ratios as we move forward. And so typically we use trigonometry, our trig ratios, to find missing side lengths. So now we're going to address the issue of, well, what if we want to know the angle measurement? So in all the previous examples, we've known the angle and we've been looking for a missing side. In this situation, we know the missing side, or we know two of the sides of a right triangle, and we could very easily find the third side using Pythagorean theorem. So the sides are not the issue. The issue is we don't know what's the measurement of the angle. All right, so here's, this is a problem taken from 480 in our textbook. I'll show it like this. So this one's all complete, so I'm just going to talk about the work I have here on the screen, kind of explain it and how we would do a problem like this. So in this situation, we have a triangle, right triangle, and we know two side lengths, and there's an angle that we don't know. So in this situation, we have the symbol theta. Theta is a Greek letter that we use to represent our angle measurements. So in case you see this keep coming up, this is not the number 0, it's the letter theta. All right, so the first thing I want to do is determine, just like we would normally do with our trig ratios, is determine which one to use, sine, cosine, or tangent. So the first thing I would do is, like I normally do, is identify the pieces I have. So if I go across from the angle, this would be the opposite, which again, there's nothing here for opposite. That would make this side here with 12, this would make this our adjacent. And that would also make this number 24 the hypotenuse. All right, so since I know I have adjacent and hypotenuse, and if I think about my SOHCAHTOA, which we just talked about, the only one that has an adjacent and hypotenuse would be our cosine. All right, so that's how I know which one to use. So I'm going to set up the problem like I normally would. So here's my equation. This is the first step. My equation is going to be cosine of the angle, which is theta, is equal to, and then here's the ratio. Adjacent, this is our adjacent over hypotenuse. In this case, that's 12 over 24. So if I just ask you for the equation, this is all you would need to do, right? So that would be done, right? Check for equation. The next step is solving, which is really what we're trying to learn here. So if I'm trying to solve this equation, we really can't solve it because this cosine and theta are stuck together. And so if I want to know what theta is, I need to somehow get rid of this cosine. And so the way we get rid of our cosine, or the way we undo our cosine, just like the way we undo multiplication, we would do a division. So this is very similar to that. So to solve for theta, we use inverse trig. All right, so inverse trig is, instead of our sine, cosine, and tangent ratios that we normally use, there's this new trig ratio, and there's actually a button for it in our calculators, which I'll show you. And you'll notice it says sine with a little -1 on it. It looks like an exponent. I'll zoom into this so we can see it. So this is our inverse trig. So our trig ratio is sine. The inverse is sine with this -1 on it. So this would be inverse sine, and this would be our regular sine. So cosine, inverse cosine, tangent, inverse tangent. Okay, so if we want to get rid of any one of these trig ratios, we're going to utilize these inverse ratios as well. All right, so since we're going to use this as a little cheat sheet, so if I know I have sine, cosine, or tangent, I know to use the inverse of it to get rid of it. So since in this problem we have cosine and I want to get rid of it, that means I'm going to use inverse cosine. Okay, so you'll notice in this problem I've done cosine, inverse cosine to both sides of the equation, right? So just like if I was multiplying something to one side, I have to multiply it to the other. If I was adding something to one side, I have to add it to the other. So this is the same idea. I'm going to take the cosine or inverse cosine of both sides. And what that does is, the nice part is the inverse cosine, it helps us get rid of the cosine that's already there. So this leaves us with just our theta, which is exactly what we wanted. But on the right side, the inverse cosine doesn't go away. It doesn't cancel out with anything. So it stays. So my exact answer would look something like this, which that's awesome because we're done. We don't need to do anything more. You'll notice we really didn't do any calculations. We just set up an equation. I wrote the inverse cosine. We didn't have to multiply or do anything. The cosines go away, and whatever is left on the right side here just stays. Right? So not much work there to do. It's just a little bit of rewriting on each step. So that would be our exact answer. And if we wanted an approximated answer, which usually it's a little bit more interesting when we do this, I would have to use the calculator. So if I was using a calculator, in this case, here's the Desmos scientific calculator, there is a function button or tab that when you touch this or click on this, it reveals some more options that we might need to use. So you'll notice there's still sine, cosine, and tangent buttons, but there's also inverse of those as well. And so all we need to do is type in our exact answer. So in this case, you'll notice I typed in inverse cosine. I just touched this button, and then it right away gave me the parentheses, and I put 12 divided by 24. Right, so 12 divided by 24. And as soon as you type that, you'll notice the answer appears at the other end. And that's it. Theta equals to 60 degrees. So really the hardest part is just making sure you know how to use the calculator correctly. So two different answers, two possible answers, and that exact answer means you don't really need a calculator. That's probably the easiest. You just solve for theta, but you still has a trig ratios inside of it. Approximated answer means we're using a calculator to get an actual answer that's easier to understand. All right, so that's pretty much what we need to know how to do. And the next few problems, examples, I'm going to go over, kind of repeat this process. So we'll practice it a few more times. I don't have the rest of them worked out, so I'm going to work them out with you in the video. All right, so, and this one actually goes back, I actually took these problems from the lesson before, from problem 470. And so there's actually 3 of them. So I'm gonna start with the first one. And so here, again, still right triangle. I've already kind of highlighted what I have. So in this case, this is our opposite, and this is our adjacent. So if I'm thinking about the SOHCAHTOA, I have to think about which one I'm going to use. And in this case, I have opposite and adjacent. So I look for opposite and adjacent, and it looks like the last one has opposite and adjacent. So that tells me right away that I'm going to be using tangent. And so I don't know the angle, so I'm going to put theta. And the fraction is opposite over adjacent, so that's 9 over 9. All right, so there's my equation. The next step would be to start to solve this. Now I want to get rid of the tangent, so this is where we're going to use inverse tangent to get rid of it. So I'm going to, let's use a different color here. So I'm going to put inverse tangent. I'm going to write it like this. It looks like tangent, except it has that -1. It looks like an exponent. Should look a little bit higher and on the right side. And then I'm going to put, so I have tangent of theta, and I have 9 over 9. So all I'm doing is copying each part that goes there, and this fraction goes in here. And so this should always work out, so those cancel each other out, and we're going to be left with theta is equal to, and so we're just going to write our exact answer. And even though 9 over 9 reduces, it's actually better if you leave it like that. No need to do any extra work. This would be our exact answer. So this would be exact. And if I want to put this in a calculator to approximate it, then I think I already have this. Let's see if this works. Oh, it's a little bit blurry. I'll have to redo this one. All right, so on this one, I plugged it in. It's a little bit hard to, oh, there it goes. All right, so if I type this in, the exact answer in, inverse tangent, so I hit the inverse tangent button, the one with the -1 on it. And again, you access that using the function tab. And then I just type 9 divided by 9, just like it's written here, and then that'll give us our answer. So hopefully that seems easy enough. So our approximated is going to be theta this is where I use a squiggly equal sign to represent. Even though it's pretty accurate, it's still okay to put the squiggly line on that one. If you didn't on that one, since it is a solid 45, that would be okay as well. The squiggly equal sign is usually more for answers that have decimals that we've been rounding. All right, and that's pretty much it. So a little bit shorter because I didn't show all the steps like on the previous one. So hopefully you kind of see how this should be a little bit easier. All right, and then B, let's do this one again. We have our angle, here's our opposite, this is our adjacent. So opposite and adjacent again, so right away that tells me this is going to be tangent. So tangent of theta is equal to 1 over 5. All right, so similar to the previous problem, I'm going to use inverse tangent. All right, you'll notice how I kind of just set it up. I just put that on both sides, and then I fill in the parentheses, the two parts. Right, I'm just putting that there, and the fraction, I'm putting it over there. And then magically, the inverse and tangent, they just kind of go away, which is nice. But on the right side, the inverse tangent sticks around. All right, so, and then that's it. So this would be, again, our exact answer. And if we wanted a approximated, we would type that into the calculator. And this would give us, let's see, I think I already have this one too. Let me resize this. And so if I type that in, we have, again, inverse tangent 1/5. That's exactly what I have here. You'll notice I'm just copying the exact answer. You don't have to put theta in here. That's not necessary. We're just working on the right side of the equation. And then that gives us here, you'll notice we actually have a decimal. All right, so this angle is not a nice number. So we're going to have to round this one. So I would put 11.3, it's probably 3.1 would be good. Because there's 2 9s there, I would have rounded it to 3 decimal places, but 2 is good on this one. So this would, don't forget this is actual angle measurement. So this would be degrees on that one. And that's it. All right, one more, and this should be it. And so the last one, we have different sides given to us on this one. We have, so opposite is over here, which is not given to us, but we do have our adjacent, and we do have our hypotenuse. All right, so again, if we're trying to decide between which trig ratio, so TOA, right? So notice if it's not near me, I just rewrite it. If it's not close to my notes, it's a little bit easier to see in front of me. So adjacent and hypotenuse, again, that's our cosine. So I think that was like our first example we did in the notes. So I'm going to use cosine of theta is equal to, and then the fraction is adjacent first. So 5 goes on top and the 10 goes on the bottom. All right, so 5/10. Even if you know it reduces, I would not even worry about that. There's really no benefit to reducing those fractions. If anything, most people that try to reduce it end up making some small error, which is unnecessary. So I'm going to, since this is cosine, the inverse of cosine is going to be used. Right? So we just have to copy the same ratio, just make it an inverse. Again, that's with the little -1. And I'm going to copy, cosine of theta and 5/10. Which then this leaves us with theta equals to cosine, or inverse cosine. If it's an inverse cosine or tangent, or inverse anything, you need to make sure you say the word inverse when you describe it. That way it's very clear on which one you're using. And so I'm going to highlight this. This is going to be, I'll label this as exact to remind you this is what our exact answer would look like. Notice this is before we use a calculator, probably like the last step before we use a calculator would be considered our exact answer. And then if I want to, if I put that in a calculator, this would give us our approximated, which is, it looks ugly. That's a nice number, so 60 degrees. All right. So this is us finding a missing angle in a right triangle. All right. So that's it for these notes. Hopefully it's simple enough. If you're really familiar with your trig ratios, sine, cosine, tangent, this is the continuation of the same thing. We're just adding another option to find missing angles, which a lot of times is actually a lot easier. All right, that's it for this lesson.